Hello, this is Professor Jen-Mei at Cal State Long Beach. In this slide, I'm going to explain the elasticity of demand calculation. We want to compute elasticity of demand for the demand function Q. We are going to be using the formula E of P equals the negative P over Q times dQ dP. By using this formula, we are already building in the decrease in demand while increasing in price. So you have to be careful at the end when you write out your solution based on this calculation, which I'll illustrate at the end. So given the formula, we're going to use what's given to us for Q of P, which is 300 minus 3P. P stays the same because P is the variable in the elasticity of demand function. What Q will need to be replaced is by the 300 minus 3P. And then we're going to multiply by the dQ dP, which is the derivative of Q with respect to P here, and that's simply just negative 3. Simplify this a little bit, multiply the top P and negative P and negative 3, we get 3P divided by 300 minus 3P. This is a general formula which then tells you the elasticity of demand, how that changes as the price changes. Now, if you were interested in the elasticity of demand at a certain price, say for example $20, we're going to plug in $20 for P. And by doing the calculation, you can see that this is equal to 0.25. And remember, this is already a ratio. You do not need to add a percentage sign at the end. So this just means it's 0.25%. Now let's look at what this number actually means. So typically we have a two-dimensional curve where the x-axis is the price, P, and the y-axis is the revenue. And this curve tells you how the revenue changes by varying the price. At the very, very center, that's when the elasticity of demand is equal to 1. And that is called the unit elasticity. That's pretty much the optimal point where you wanted to price your product in order to get the maximum revenue. If you look now to the right of this curve, you can see that the revenue decreases as the prices increase. So this area, or this region, has elasticity of price greater than 1, which means that your demand is elastic. It's very sensitive to the price change. Particularly if you increase the price, then you're going to get a lower revenue. On the other hand, if you look at now, it's the left-hand side of the curve. That's where E of P is less than 1, and that is called inelastic. What that means is, if you were to increase the price from 0 towards the optimal price, which is where E of P is equal to 1, then you should expect the revenue to increase all the way until the maximum revenue occurs. What this means is that your price change is insensitive. Alright, now that we've understood what this means, we can go back to actually answer the question. Since E of 20 is equal to 0.25, which is less than 1, this falls to the left region of this curve, which means that your demand should be inelastic. And to actually interpret what 0.25 means in a complete sentence, this actually means that for every dollar increase in price, the demand will decrease by 0.25%. And the reason why it's decreased, although it's a positive number, is because remember that we're using the formula that has the negative sign built in already, which is already telling you that it's a decreasing. So that's why, remember, to interpret it correctly, that you need to use a decrease by that number %. This concludes this problem.